This machine made the chip inside your iPhone. So let me show you exactly how this $380 million machine works. There are only 200 of these machines on Earth, outright. And DHIS is the only one that can make your iPhone chip. It costs $380 million. That's heavier than a fully loaded 737 airplane. It took 3 Boeing 747s just to deliver the parts. And it can etch patterns 1,000 times thinner than a human hair. I'm revealing the $380 million process that powers your entire life. This facility produces $23 million worth of chips every single day, made by a Dutch company called ASML. Not Intel, not Samsung, not even China can replicate this. Apple, Nvidia, AMD, every major tech company depends on the IS machine. This wafer will become over 500 individual chips. Each chip has 16 billion transistors. Your phone, your car, your laptop, they all need chips from this machine. This is an EUV lithography system. EUV stands for extreme ultraviolet. This machine uses light so powerful, it can etch patterns 1,000 times thinner than a human hair. To put that in perspective, if you scaled this machine's precision to the size of Earth, it could place a golf ball on the moon with millimeter accuracy. But here's what makes it truly impossible to replicate. Inside this chamber is a laser that generates 50,000 pulses per second. Each pulse creates a droplet of molten tin, smaller than a grain of sand. Then a second laser hits that droplet with such intensity, boom, it vaporizes, creating extreme ultraviolet light. Now, the engineering required to make this work is absolutely insane. The mirrors inside are so smooth that if you scaled them to the size of Germany, the biggest bump would be less than 1 millimeter tall. Each layer is just a few atoms thick. The manufacturing process involves over 5,000 suppliers from 18 different countries. A single machine requires 40 shipping containers to transport. CH-3 Boeing 747 cargo planes just to deliver all the parts.
And once it arrives at the factory, it takes another 18 months to install and calibrate.
350,400 wafers per year from a single machine. Each wafer becomes over 500 individual chips. Do the math. That's 175 million chips per year. If each chip goes into a device worth 1,000, this one machine is responsible for 175 billion worth of products annually. One machine, $380 million, powering $175 billion in products. But here's the secret. Inside this massive machine is a sensor that makes it all possible. Let me show you something most people never get to see. Right here, this is the sensor that controls everything. So how does your iPhone chip actually get made? It all starts with this, ordinary sand.
Silicon dioxide, the same stuff you find on a beach.
First, that sand gets purified at temperatures exceeding 1,400 degrees Celsius. A single impurity at the atomic level could ruin an entire chip. This entire process takes about 12 weeks. 12 weeks. The wafer moves through hundreds of different machines, each one performing a specific task. And throughout this entire journey, every step happens with atomic precision. And the wafer is never touched by human hands. Everything is robotic. By the end, what started as sand has been transformed into the most complex object humanity has ever manufactured. It turned into billions of transistors. Each one switching on and off billions of times per second. Enabling you to scroll through Instagram. Or FaceTime your mom. But remember that tiny sensor I showed you? Let me explain why it's so critical. Remember this sensor, the $8,400 one? This little sensor is the reason this entire process works. We're talking about measurements so small that if you lined up 10,000 of them, then trin that equal the width of a human hair. This sensor checks the laser position 1,000 times per second, making micro adjustments constantly. Vibrations from a truck driving past the building can ruin a wafer. Even the Earth's rotation affects the precision. The machine sits on shock absorbers that can detect vibrations smaller than an atom. Then, an atom. Controlled to within 0.0001 degrees Celsius. The air pressure, humidity, even the molecular composition of the atmosphere inside, everything is monitored and controlled. And all of this happens automatically, 24 hours a day, 7 days a week, 365 days a year. This machine processes one wafer every 90 seconds. That's 960 wafers per day. $350,400 wafers per year from a single machine. That's 175 million chips per year. Do the math. If each chip goes into a device worth $1,000, this one machine is responsible for $175 billion worth of products annually. One $380 million machine, powering $175 billion in products. And the sensor ensuring it all works perfectly? $8,400. That's over 20 million times return on that one component. So why does any of this matter to Yayou? Your iPhone has a chip made by this machine. Your car has over 3,000 chips made by these machines. Your laptop, smart TV, wireless earbuds, smartwatch, all of them depend on chips that can only be made with this technology. Them are in Taiwan at a company called TSMC. When you hear about chip shortages that delayed car production, that made graphics cards impossible to find, it all traces back to these machines. Not enough of them. Not enough production capacity. China has spent over $100 billion trying to build their own version of this machine. They can't do it. That's why this machine costs $380 million. It's not just a machine, it's geopolitical power. It's the foundation of the digital age. ASML, the company that makes these machines, produces about 50 units per year. That's it, 50. Global demand is over 100, so there's a waiting list. Tech companies place orders years in advance, hoping to secure one. And if you're not Apple, if you're not Samsung, if you're not one of the top players, you're not getting one. This creates a winner-take-all economy in tech. The companies with access to these machines dominate. Everyone else falls behind. And that gap is only getting wider. Right now, somewhere in Taiwan, one of these machines is etching circuits onto silicon, layer 87 of 100. In 90 seconds, that wafer will be complete. It will move to the next station. And 12 weeks from now, it will become the chip inside someone's new iPhone. That phone will take 4K video, run artificial intelligence, connect to satellites in space. And it all traces back to this moment, this machine. This $380 million marvel of human engineering. This is the machine you never see. The technology that powers everything but gets zero credit. Only 200 exist. Only one company can make them. Thank you for joining us today. I hope you've enjoyed this glimpse behind the scenes. Be sure to subscribe for more factory secrets.